Am I good?
Mr. Rezac, let's go for it.
We had to fix the Space Telescope imaging spectrograph on the Hubble back in May 2009. We developed a short one of the electronics boards. Typically, with Hubble, we pull one box out and put it in, but we did not have the scheduled runway or the budget to build another science instrument. So the fix was to take the STIS apart and fix it on orbit. It was never intended to happen. It was put together using a whole bunch of non-captive fasteners. That's little screws, and when I say non-captive, it means when you back them out, they're going to float away. Bad thing to happen in the aft shroud of the Space Telescope, because if one fastener got up into the optics core, we lose a very expensive international asset. So we came up with this idea. It's called the STIS fastener capture plate. We installed this plate, designed the plate so that all these holes were directly lined up with the screws of the fasteners underneath. We'd attach it to the board that we had to remove, and then pull all the fasteners out, and they would get captured. These holes you see are big enough to allow a bit to go through, but small enough to keep the screw from floating away. When we had all the screws removed, we'd take the fastener capture plate away, and the panel that we removed came with it. So we had a bit of a sandwich. Alright, all the screws were captured between the plate and the fastener capture plate. The PGT is the pistol grip tool. This is the go-to tool for astronauts. Every guy ought to have one of these in their garage. It's got an onboard computer that not only is programmable for everything you're doing that day, but it records everything you've done. Turns, turn direction, braking torque, running torque, seating torque, records it all. You get back inside, plug it into your laptop, and download it. Okay? This is the tool that they all love. The problem was Mike Massimino used it for the first time in training, and he said, "Ed, this tool's too big. The profile is too big. I can't see where I'm putting it. So I need a smaller tool." So the folks at Goddard developed the mini power tool. It's smaller. Mike says, "This is great. I can see around it now. I can see where I'm going. And wow, it turns really fast. But it's dark here inside the aft shroud of the telescope. I can't see." So the next time we went down, we had the tool modified, put lights on the front of it. Mike says, "This is great." So he was able to remove all 111 fasteners, remove the electronics board that had the short, replace it with a new one, and instead of putting another panel with 111 fasteners, he put one on that had 2 quarter-turn knobs, held it in place.
That answered my question. I said, did you take all the screws out, and how did you get them all back in, but you didn't use them?
Didn't need them. We just took it out, had that sandwich. What was really cool is, I remember the early days of Space Off with this guy and Jack Louse with shuttle missions. I didn't work Apollo, but if we were watching everything they do, CCTV cameras, and if they didn't want you to see what they were doing with their hands, they just turned their back to the camera. So they fudging things a little bit. But then they installed the cameras on their helmets, so they can't get away with anything now. We can see everything they do. But it was remarkable watching Mike Massimino pull this away from the instrument. His lights were shining on it, and you can see all the fasteners just kind of doing a little dance inside there, sparkling. It was a good feeling because we were successful and almost looked like there was a celebration going on there in Mike's hands. It's crazy.
What kind of battery life did you get out of it?
Excuse me?
How much battery life would you get with these?
They're lithium batteries. They're pretty powerful batteries. When they come inside at the end of their 6-hour EVA, they
take it out and recharge it?
Release the battery, stick it in a charger, and then the next day, put it back in.
So you could analyze every torch that you go, you must have missed one because we don't have the proper sequence.
That's why we record it. Plus, they're doing the callbacks.
That would make for a tough class.
They're doing the callbacks real time. They're doing turn counts.
And what was this beast for?
This is the same concept, but we did this with the Advanced Camera for Surveys, ACS. We had to remove a fastener, a cover plate that had 32 non-captive fasteners.
And then finally, this little beastie.
We train the astronauts 10 to 16 hours for every single hour they spend in a spacesuit doing an EVA or a spacewalk. With all that training, we try to keep our tools as EVA friendly as possible. Because we had different size fasteners with different screw heads, we had torque set, hex heads, we had them color coded. This is a bit caddy that held the different bits, and they're all color coded to match the proper size. When the astronauts decided they needed a particular bit, they would take the tool, install it into the bit, release it from the bit caddy, and it is locked on there. It cannot come off. The only way it can come off is to engage it again, slide the pin in to release the locking feature, and pull it out. The bit caddy is attached to their mini workstation on their spacesuit, so they've got it right there within easy reach.
Spectacular. Thanks, Ed.
Sure, man. You are welcome, Robert.